Hi, I'm Paul Brodie. We're in the shop, Mitch behind the cameras, and we're doing an episode on Excelsior. Specifically, how the jack shaft works. And this is a part of it. I've been working on this now for a day and a bit. And on these videos, if I did all this, Mitch would be here for hours. That just wouldn't work out. So it's going to be a bit of a slideshow, and then I'm going to do some work in the lathe, going to use the fixture, and then we're going to do some silver soldering. So what is the jack shaft? The jack shaft is how the engine gets geared down so the back wheel doesn't spin too fast. So this sprocket has to go on here. And I think what we'll do now is walk over to the bike and I'll show you where it all fits. Then it'll make much more sense in your mind, okay? Thanks for tuning in. Okay, so here's the engine sprocket, and the engine sprocket has to come back to here. This is the eccentric. Do you see how the hole is offset from the middle? And this is the shaft that goes into there. And that's when you move the eccentric, that's how you get the tension on the chain or the right adjustment. So this goes here like that. So the chain goes from here to here. And then this sprocket, when this is machined down, that sprocket is silver soldered on. And that goes to the back wheel. That's where the chain goes. So that's basically how it works. It's a little bit complex, you might say. This is not an easy piece to make. I'm going to run you through what goes on, all the processes I used in the last day and a half or so. And that's the jack shaft mounted on the eccentric. All right, so how I start out here, I've got a blank. You know, you can just buy these. I forget how much it was, but it's a 530 chain. If I put my vernier over there and lock it, it's got quite a bit of thickness, and this is a 520. Can you see how much narrower this is? So that's one of the things I have to do. I have to machine this down to the right thickness. And then the hub, I start with some DOM tubing. This is, it's a nice piece of tubing. It's not chromoly. It's sort of halfway between 4130 and mild steel. It machines quite well. It's also, it's seamless. That's why it's called DOM, which is drawn over mandrel. No seams. So I'm going to give you a little slideshow to show how this ended up as this, and I've got a bearing that goes in each side. I bored out this so it fits the bearing. Okay, I'm going to give you a little slideshow now. I've got a drawing here. This is for the hub, and it shows all the specs and stuff like that. Then I've got notes to myself. This was done in 2015. So I think that's the last time I made one of these. That would have been for Excelsior number 5 that took me 11 years to sell. Okay, here's the hub, and it's mounted in the chuck. It's a 3-jaw chuck, and I'm boring it out. It's a rough bore. And you can see here, I've machined down the OD here, and that's what fits on the sprocket. That's where the sprocket fits on. Here's the fixture, and I've got the sprocket mounted, and what I've done is machine, it's basically a 1/16 inch off each side, and I'm holding it with Allen screws, and there's some spacer blocks in behind where the Allen screws go. And now that I've got it machined down, I hold it in the middle now. I take out the blocks, and I'm machining a relief from here to here. It's a little bit narrower. It's like 25 thou narrower. And I machined a chamfer on the end, and that's where the chain goes. And you can see here it's a bit rough. and I take a file, and you see how I smooth it out a little bit. So I go around the whole sprocket, and I smooth out those machining marks because it's an interrupted cut, so it doesn't want to cut cleanly. It leaves little grooves. Then I put it up on the mill in the rotary table, and I use an 1¼ inch hole saw, and I cut 7 holes. And I was going to use the boring bar off to make a little nicer cut, but I think my hole saw was pretty sharp and it did a nice job, so I just left it like it is. Then I put the sprocket onto the hub, I put the lock ring on there, and I silver soldered everything. Got a number 1 tip on my torch, and it turned out quite well. Then I put the 4-jaw chuck on my lathe, and I'm holding the back part of the hub here. I dial up the ID, and what I found was it was a little bit out of round, and that's from the silver soldering. And so I got it as close as I could, and then I bored out for the bearing. And the bearing is 2.125, and I bored it to 2.126 because it's going to get nickel plated, and usually when they nickel plate, they put half a thou aside. So the bearing should just go in. That's going to be size on size, and it usually goes in a little bit tight. And that's the end of my slideshow. So we'll get back to working on this piece now. I'm gonna mount it on the fixture, and then we'll put it in the lathe in the 4-jaw. I'll dial it up, and we'll just machine the OD. That's what I'm trying to say. Got a little bit of lathe work to do. I have 3 holes here. These are 6mm threaded holes, and I have spacer blocks. See here how the hub is a little bit extended from the sprocket. So I need to put these spacers there. So we'll do that. We'll mount it on this, and then we'll go over to the lathe. Okay, that looks good. So I got 6mm Allens with large washers here. I'm going to dial up to the ID because it was machined from the other side. The OD might be a few thou out, so I need to dial up to the ID. Okay, we're going to walk over to the lathe, 4-jaw, a dial indicator. Let's go that way. I bought this when I was 18 years old, and I still have it. Still use it. That's what happens when you buy good tools. They can last a long time. Okay, so, oh, it's pretty close, not bad. So when the needle goes clockwise, that means it's coming towards me. And we'll put it like that. And so when the needle comes clockwise, I have to make this tighter. Can you see how it goes back a little bit? Then I go around to the other side, and I give it a little loosen. So it's just back and forth, a little bit at a time. So it doesn't have to be absolutely perfect, but if it's within a thou, that should be okay. Okay, that's within a thou, so we'll leave it like that. So I'm putting the dial indicator up against the carriage, and then I set this at 0 approximately. Okay. So do you see how I bring this in? And it comes to 0. that's good. And then what I do, I need 410 thou. So each of these is 125. So I go 3, 1, 2, 3. So I'm at 375. Then I go an extra 25 plus 10 to the 35. So then that's 410 thou. So when I use the automatic feed and the indicator goes to 0, I've gone in 410 thou. Does that make sense? I know it's a bit technical, but that's part of machining 101 or 201, whatever you want. Okay, so it's got to fit the sprocket, right? So the sprocket is 2.475, something like that. 2.47778. So we go to 2.475. It just has to go over and then get silver soldered, so it doesn't have to be a press fit or anything like that. We've got 285 thou to come off, so that's one revolution of the cross feed. So we'll set I'll touch the tool, then I'll set it to 0, take some cuts. There we go. That's what I want. All right, we'll see how this all fits together now. I'm fluxing it up. Oh, that fit quite nicely. Yeah. So this is the lock ring. It's meant to look like a lock ring, but it's just doesn't have threads or anything. Everything just gets silver soldered. So the ring is a little smaller than the sprocket, but that's fine. Oh yeah, the sprocket has a good ring to it. Let me see if I can show you. That's a good ring. That's a nice piece of steel, sprocket steel. There we go. There, can you see it working? There we go. On silver solder, you don't have to get it super hot. It's got to be a little bit red. Okay, so we're going all around. Now we come down here. Okay. Oh, I think that's it. I've done a 360. That's our video. Thanks for watching. Hope you like it. Rich and I like coffee. If you buy us coffee, it really helps the channel a lot. And please like, subscribe, tell your friends. See you next time.